The third step in our hypothesis testing is to compute the test statistic. And this one, it's really a question of choosing the right formula and then putting the right numbers in the right places in that formula. So to choose the formula, it's going to depend on what parameter we're testing. So this goes back to what our alternative and null hypotheses look like. If we're testing a mean, then this is our formula. If we're testing a proportion, then this is our formula. And if we're testing a standard deviation, then this is our formula. So in all of these formulas, the symbol on the left side, so the t0 or the z0 or the chi-squared 0, is going to tell you which distribution to use later. So for the t, that means you'll use the t distribution. For z, that means you'll use the standard normal distribution. And for chi-squared, that means you use the chi-square distribution. And that will be important when we get to the next step, step 4. When we're actually calculating in this step, we need to know which numbers go where. So on the right side of each of these formulas, anything with a subscript 0 is going to be the value from the hypotheses. So the number in the null and alternative hypotheses is going to go in here in place of the mu0, or in this formula it would go here in place of the p0s, which happens 3 different places, and here it would go here in place of the sigma 0. Anything without that subscript 0, so the x bar here, the s, the n, the p hat, and the n here, and the s here, those all come from the sample data. Let's do an example of finding a test statistic. So in this one we have some sample data, and our null and alternative hypotheses from step 1 were that mu is equal to 195 for the null and mu is less than 195 for the alternative hypothesis. So that tells us our parameter that we're testing is a mean. That means the formula for the test statistic that we want to use is this one. So for the mu0 in this formula, that number comes from the hypotheses, so that's the 195. Then the other values all come from our sample data. So if we go back up here to our sample data information, we had a sample mean weight of 192 pounds, so that's going to be the x bar. A sample standard deviation of 16 pounds, so that's going to be the s. And we had a simple random sample of 120 passengers, so our sample size n is 120. So if we plug all of those things into our formula, we end up with a test statistic of -2.05. Here's another example. This was from the problem about the herbs. Here was the null and alternative hypotheses. These both involved p, which is a proportion. So that means the test statistic formula we're using is this one. And you can kind of tell a lot of times in these ones whether the formula kind of matches what you had up here. So if this one, if we had p in our hypotheses, then our formula should have p's in it. The p0 comes from our hypotheses, so that's the 0.189. The p hat is the number of successes divided by the sample size. Since in this problem they didn't give us a percentage or a proportion from our sample data. They just gave us how many responded favorably and the total size of the sample. So we actually have to calculate our p hat, and then our sample size was 1100. So if we plug all of these things in, we get a test statistic of 0.55. Now one thing that's important, especially when you're doing tests with proportions, but also in some of the other hypothesis testing, you can't round too much in the middle of your calculations. If you're going to round at all, don't round very much. Notice here I took the top and the bottom parts of this out to 5 decimal places. Look what happens if I round it a lot more than that. So if I had rounded the top and the bottom of this just to 3 decimal places, then I get 0.50 for my test statistic instead of 0.55. And that's not going to be close enough to get you the right answer. So just be careful about that rounding. Okay, one more example for this. This is our test for the standard deviation. So here are null and alternative hypotheses. This had a sigma in it, so we're going to use the formula for the test statistic for a standard deviation. Our sigma 0 comes from our hypotheses, so that's the 3.2. The S and the N both come from our sample data. So in our sample data, we had a random sample of 60 cans, so that's our N. And it actually gives us some extra information in this. It says that the mean volume was 356.2 milliliters. That doesn't get figured into our problem anywhere because what we're testing is the standard deviation. So what we're going to use from this is our sample standard deviation of 3.5. So that is our S that's going to go into our formula. So if we plug all of those things in, then we end up with a test statistic of 70.58. And again, we don't want to round too much. Here's an example of what can happen if we round this a lot more. So if we rounded the top of this to just 723 and the bottom to 10, then we get a test statistic of 72.3. That's far enough off from this that it's probably going to give us a significantly different result. So this is not close enough. We don't want to round this much.